Hello friends, so here is another question on KVL and KCL application to circuits involving dependent sources. So here we have been asked to find the current I flowing through this 5 ohm resistor, this current flowing away from this dependent voltage source, voltage dependent voltage source. So let us redraw the circuit. 3 ohm, 2 ampere, 4 volt, 2 ohm, 5 ohm, 3Vx. So here we have been asked to find this current I, okay, and this is the dependent parameter, the voltage drop across this 2 ohm. This is a voltage dependent voltage source, and this is the important parameter, the voltage drop across this 2 ohm resistor. Okay, now here current I is flowing up to this point, this node. Then 2 ampere flows because of this 2 ampere current source. So through this 4 volt and 2 ohm branch, the current flowing is I minus 2 ampere. Okay, so now we can apply KVL with the polarity assigned like this in this closed loop, right hand closed loop. So the KVL equation will be three Vx minus 5I minus 4 minus Vx, okay, for this voltage drop Vx is equal to 0. That implies 2Vx minus 5I minus 4 is equal to 0. Okay, now another important thing is to bring the equation in terms of one parameter. See, here it is Vx, here it is I, so that we cannot solve such an equation. So we have to bring this equation in terms of one parameter. So either we express Vx in terms of I or I in terms of Vx. Okay, here if you see, the voltage drop across this 2 ohm resistor is equal to Vx, which is equal to 2 into I minus 2. This is the important relationship. Vx is equal to 2 into I minus 2. So we'll replace it here. 2 into I minus 2 minus 5I minus 4 is equal to 0. That implies 4I minus 8 minus 5I minus 4 is equal to 0. 2 into I minus 2, that is 2 into 2, 4 into I minus 2, 4I minus 8 minus 5I minus 4 is equal to 0. That implies minus I minus 12 is equal to 0. That implies I is equal to minus 12 ampere. We have got the value of I. I is equal to minus 12 ampere. So what it means, this negative sign, I is equal to minus 12 ampere, the result that we got, what it means is that the magnitude is right. Okay, the magnitude of this value, current I, that is equal to 12 ampere. Okay, we get the modulus of that, we'll get 12. That is correct, but the direction is wrong. It is actually flowing in the opposite direction. The actual direction is like this, like this, flowing into this voltage source, not away. So the actual direction is like this, I is equal to 12 ampere. This direction which is given in the question is wrong, okay, because the sign is coming minus. So the actual direction is downwards, flowing towards the positive terminal of this 3Vx voltage dependent voltage source. Okay, so I have discussed it many times that whenever you get an answer, the current value is coming minus 12 ampere, it means the magnitude is right, but only thing that is wrong is the direction. That's why the minus sign. So the assumed direction is wrong, the actual direction is opposite to the assumed direction, the given direction. Okay, so here we have solved the circuit. Again, basic combination of the application of KVL and KCL, and we solve the circuit, and behavior of dependent sources, nature of dependent sources. Okay. Hello friends, so here we are with another question on Kirchhoff's law application to circuits involving dependent sources. So here we have the circuit, and this is the dependent voltage source, current dependent voltage source, and we have been asked to find the voltage across these two terminals. Okay, so let us solve it. So we'll redraw the circuit. Okay, this is 1 ampere, this is 20 ohm, this is again another 20 ohm, and this current dependent voltage source this is 20 IV, where this current here is IV. Okay, we will highlight it in red because it is important, and we have to find out this open circuit voltage. Okay, so here this is the current dependent voltage source. Okay, current dependent voltage source. Okay, this one, and it is dependent on this current here. Okay, flowing through the 20 ohm resistor downwards. Okay, this is the important dependent parameter. Now the voltage across these two terminals is V. It means the voltage as at this node is V, and also the voltage at this node is V. Why? These two nodes are short circuited, there is no resistor in between, so no voltage drop. So these two nodes, they are at the same potential, they are short circuited. So now here we will apply KCL, Kirchhoff's current law, at this node V. Okay, so here this 1 ampere current is flowing towards the node. Okay, this 1 ampere current is flowing towards the node. This IV current is flowing away from the node downwards, and there is another current flowing through this node. Okay, this one, from here to ground, and this value will be V minus 20 IV by 20. This is this current. Okay, this current value. So if we write the KCL equation, we have to get the value of this IV. We have to express IV in terms of capital V. So here if you see, IV is nothing but V minus V ground by 20. This potential minus ground potential divided by 20, IV here. So that is equal to simply V by 20 ampere, IV. So we have got IV in terms of capital V. This is an important relationship. So the KCL equation here will be Okay, 1 ampere is flowing towards, so that will be on one side, and all the other things, that is IV plus V minus 20 IV by 20, they are on the other side. This is the equation. So now let us bring the equation in terms of capital V, because that's what we want to calculate. So 1 is equal to V by 20, that is IV from here, plus V minus 20 into V by 20 by 20. See here, V minus 20 IV by 20. So we have to replace IV with this value, V by 20. So we replaced V minus 20 into V by 20 by 20. So here 20 will get cancelled, V minus Y will be 0. So this whole term will become 0. That is very interesting. See, this whole term will become 0, this part. So we will be left with 1 is equal to V by 20. That implies V is equal to 20 volt. Okay, this voltage V is equal to 20 volt. So we calculated the result. So again, it is basic knowledge of how dependent sources they behave, on which parameter they are dependent, then basic understanding of Kirchhoff's law application, in this case KCL, and then we solve the circuit.